All right, we've been looking at solving inequalities that have variables on both sides. We're going to look at a few unique situations. So I've got this problem here. 2y minus 2 is greater than or equal to 2 quantity y plus 7. We're going to solve that. We've got a variety of ways that we can do it. I did mention at one point that you could divide both sides by 2 first, or if we look at the, I guess I'm looking at the right side of the inequality here, we could divide both sides by 2 first, or we could distribute first. And both ways do work. One thing that you have to be careful of is if you don't want to distribute, be careful, make sure that this is going to work out well for you. If you divide by 2 over here, if these numbers don't pair well with 2, they don't work well with each other, then that's maybe not the best way to do it. It could be, but it depends on the problem. In this case, it does. And so I'm going to do it a different way. So I'm going to solve for y. Rather than distributing first, I'm going to divide both sides by 2. Let's see what happens. So I'm going to divide 2 divided by 2. It's just going to give me 1. And so those 2's will go away. We'd have y by itself. And over here, same thing. 2 divided by 2, we're just going to get 1. Now, if you distribute first, go ahead and do that. That's fine. You're going to get the same result. Divide here, 2 divided by 2 just gives me 1. So I've got y plus 7 left over there. I get all my y's together on both sides. I'm going to minus y from this side, and minus y from this side. And y minus y is going to give me 0. Give me nothing. Y minus y is 0 y's. It's nothing. So I'm left with negative 1. It's greater than or equal to 7. Is that true? Is negative 1 greater than or equal to 7? No. No, that's absolutely wrong. Negative 1 cannot be greater than or equal to 7. However, no matter how you solve this inequality, you're going to be left with something that's definitely not true. And even if we look right here, at this step right there, if you take any number y and minus 1, we'll say 5. If y was 5, 5 minus 1 is 4. And if we take that same number, 5, for y over on the right side, 5 plus 7 is going to give us 12. But 4 is not greater than 12. It doesn't matter what value you pick for this y and this y, it's not going to work. And this is what we call a contradiction. We've used that word before. Contradiction, it means that it cannot happen. It's wrong. There's no way that that's correct. There's no way that that's true. Doesn't matter what y is, this will never, ever, ever work. Since negative 1 is not greater than 7, since that solution is not true, it means that my original problem, my original inequality will never, ever, ever be true. So this is a contradiction. In fact, that's what we have right here in your notes, identity and contradiction. We've used these before, so I'm not going to spend a lot of time on it. Contradiction is when it will never work. 7 is not less than 0. Identity is when it is always true. Now here's one place where you have to be careful, and I did this a little bit in class today at the beginning, but when we had equations and we solved equations, we said, well, if 1 equals 7, that's not true. 1 doesn't equal 7, that's a contradiction. And if 6 equals 6, that's always true. So that's the identity. And that was with an equation, and that worked great. It was pretty easy to tell. If they were different numbers, not true. If they were the same numbers, always true. With the inequalities, you have to be more careful. You'll notice that in both of these instances here, the numbers are different from each other. 1 and 7 are not the same. 7 and 0 are not the same. What's really important is we look at the inequality that's written there. 1 is less than 7. That's always true. 7 is less than 0. That's never true. So look at another example. So we're solving the inequality. 2x minus 7 less than or equal to 5 plus 2x. We're going to get our x's all together first. And this is where it does help to get the x's together first. You'll get to the answer faster. I end up with negative 7 is less than or equal to 5. Is that true? Is negative 7 less than or equal to 5? Yeah, that's true. That's always true. So this is the identity. Because no matter what, doesn't matter what value we choose for x, this will always work. Let's try the next one here. In fact, why don't you try the next one? Pause it, try this one on your own. Okay, so I mentioned before that whole dividing both sides to get the variable by itself without distributing. If we look at here, if we look at the right side here, if I try to divide both sides by 3, this becomes really messy. I do not recommend doing it that way. So we have other tools, we have other methods. So I'm not going to, whoa, where am I? Here we go. I'm not going to do it that way. I'm going to have to distribute because it's just going to be a simpler way to get there. And so if I distribute through the parentheses, I'm going to do 3 times 2, 3 times 7. I'm going to get 6y plus 21. And if I do the same thing over here, I'm going to distribute first. I get 6y minus 4 minus 4. Here we still have this minus 4 here. So that's still inside the problem. Now we can combine some like terms. If I look at the right side of the inequality, nope, can't combine anything over here. 6y and 21 are different, can't combine those. But look at the left side of the inequality. I see that I can combine these terms together. Minus 4 is the same as negative 8 or minus 8. So if you have 6y minus 8 is greater than or equal to 6y plus 21. Now some of you might already be thinking, well, I know the answer now. What I would like to see, showing your work, communicating every step and whatnot, what I would like to see is get it down to one thing. One thing is greater than one thing. Right now I have 2 things, they're called monomials, but 2 monomials is greater than 2 monomials. That's 2 things. I don't want 2 things. I want you to get down to 1. So I'm going to get my y's together first, minus 6y minus 6y. I end up with negative 8 is greater than or equal to 21. Now we have to ask, is that true? Is negative 8 greater than or equal to 21? There's no, that is not true. So there's a contradiction. Contradiction of terms. Negative 8 is not greater than or equal to 21, so my original inequality cannot be correct. You've got 2 more here. Give these 2 a try. I assume that you paused it. If you haven't already, pause it. Try these 2. Do it on your own first, then watch what I do and see if you get a similar answer. Okay, I'm going to distribute through the parentheses. Again, if you tried dividing by 4, you could have done it, but they don't quite work out as well as they could, and so we're going to go ahead and distribute. Distribute through the parentheses. 4y minus 4 greater than or equal to 4y plus 2. I look to see if I can combine like terms. On the left side, 4y and 4, nope, can't combine those like terms. On the right side, 4y plus 2, nope, can't combine those like terms. So now I get my y's all together onto one side, minus 4y, minus 4y. I get that negative 4 is greater than or equal to 2. Is that true? No. Negative 4 is definitely not greater than 2. So there's a contradiction. You can see how what we did in chapter 2, the first half of chapter 2, really makes a big difference here in that we are solving the same way we did. We're still using the same terms, contradiction and identity. Now we just have to think a little bit harder because they're not equal. They're unequal inequalities. Last one here. Again, you should have tried these on your own. We have nothing to distribute, so that's nice. I'm just going to get all my x's together. I'm going to get negative 2 is less than 1. Is negative 2 less than 1? Yes. Yes, it is. So we call that the identity. There we go. So it doesn't matter what value we choose for x, this will always be true. There's an infinite number of answers that will always work for this problem. You can choose any number for x, and it will always, always, always be true. Same thing with the contradiction, or the opposite, I guess, for the contradiction. You could choose any value for y. It will never work, so there's no solution for that answer. Okay, Rick bought a photo printer. I'll let you read it. I won't read it to you. Go ahead and read it. Okay, I'm assuming you either paused it or you read it on your own. I found my question mark. There it is. So how many photos must Rick print before his total cost is less than, hey, there's a math term, is less than getting prints made at the photo store. So printing. So he's printing, and then he's going to the photo store. And I want to know, when is the printing less than the photo store? So printing is $186.90. And it costs him 29 cents for each photo, because he had to buy the printer, plus it's going to cost him 29 cents per photo. I'm going to use P for photo. A photo store charges 55 cents for the print, but you don't have to buy the printer. So a photo store is 55 cents for every photo. Now, if I only print one photo, it's a lot cheaper to get one photo printed at the photo store than to buy the actual printer. But we want to know, for Rick, when the printing will be less than the photo store. The photo store. So that's our question. That's our inequality. We've got the printing situation on the left side. We've got the photo store, on the right side. And it told us what symbol to put in between, less than. So I'm going to solve this inequality, because we can solve multi-step inequalities. And then we'll check and see if our answer actually makes sense in the real world. So I'm going to work backwards through PEMDAS. I'm going to subtract 186. No, I'm not. I'm sorry. If I subtract 186.90 from both sides, that doesn't quite match up because they're not like terms. So I should not do that. Erase what I just did. That would be wrong. I'm going to get all my variables together first. So I'm going to minus 29 p's from both sides. It's a lot of p's. Okay. And I'm left with 186.9 is less than, oh, what would I get there? 26. 0.26p. Double check my math, but I'm pretty sure that's right. Now I need to get p by itself, so I've got 0.26 times p, and I'm going to divide both sides by that 26 hundredths. And I'm looking at a calculator here quick, 186.9 divided by 0.26. Okay, so I'm going to divide 0.26, showing my work. Even though I'm using a calculator, I'm still showing my work. And that means that I've got 718.846. However, let's look at the situation. That is correct. I mean, that's the correct result when you do the math. But if we think about the real world, you can't print 718 point something photos, 118.8 photos. That doesn't work. Can't print up. Well, I suppose you could, but I don't know why you'd want to print an eighth of or 8/10 of a photo. So we want to know, how many photos does he need to print before his total cost is less than the photo store. And so at what point is it going to be more cost effective to use the photo store, or to use the printer, excuse me. So if you print 718 photos, that means that it's still going to be cheaper to use the photo store. If he prints more than 718, if the photos are greater than 718.846, it's going to be cheaper to buy the printer. I'm going to say that one more time. If you do one photo, if you print one photo, it's definitely going to be cheaper to go to the photo store. 55 cents for one photo. $186.90 for the printer, plus 29 cents for that one photo. That's definitely going to be more expensive to buy the printer. It's going to be less expensive to go to the Photoshop. So that same idea applies here. How many must he print? Well, if he prints more than, and I'm talking through this a couple times because I don't want to confuse people any more than I have to. if he prints, P, if he prints more than 718.846 photos, it's going to be cheaper to buy the printer. So we would say that he'd have to print 719 photos before it's cheaper to buy the printer. Okay, that may have been harder than it needed to be, but those are hard questions, but those are very real-world questions. You've got 4 problems here. They're a little fuzzy, but again, go to the book, page 198, 31, 32, 33, 35, and give this a try on your own.